Hey folks, so in this short video I just want to do some quizzes concerning this silly proof to get a feel for how theorem application works, these proof objects. So let's start. So here's what we have. A and B are natural numbers. H1 is the equality that says that A is equal to B. H2 is the equality that B is equal to 42. Now your mind may jump immediately to like A is equal to 42, and I agree. Right? No doubt. Now here I've included transeq as a hypothesis just so we have the type right in front of us, right? So we don't have to go hunting for it, you don't have to look it up. So the first question I want to ask you is, what is the type of this proof object? Transeq nat A, B, 42, H1, H2. So might feel like a little panicky, like this got really complicated. He's saying proof object. Proof object is just a fancy way of saying a value that represents a proof, right? So H1 is a proof object. H2 is a proof object. Now, if we start applying transeq to arguments, that's also what we would call a proof object. So I'm just asking you to say, well, okay, let's just do the substitution. It's the exact same model of evaluation we've had the whole time. So you'll plug in a nat for x, you'll plug in A for n, B for m, 42 for o, and then the core question is, okay, for this n and m, well, n we decided was just going to be A, and m we just decided was going to be B, and o we just decided was going to be 42. So like, will these H1, H2 be well typed? What's the final type you get here? Pause the video as necessary. Okay, so in this case it checks out, right? So A will be n, B will be m, 42 will be o. H1 is a proof that A equals B, which is the same as n equals m. And H2 is a proof that B equals 42, which is the same that m equals o. So our conclusion will be n equals o, that is A equals 42. Let's see. Did we do it? Nailed it. Oh, made my window too big. No, Emacs. Hurting my feelings. Okay, next one. A little more confusing. So look at the text. Transeq nat D42A H2. Two things are happening here. On the one hand, we've done a partial application, right? Transeq expects two proof objects as arguments, right? The n equals m and the m equals o arguments. We're only supplying one. And we've reordered the arguments. Pause the video if you need to. Okay, let's see. Well, the answer's right here. Let's see that Cock agrees. Indeed. Cock says, yes, the type will be 42 equals A, B equals A. So answer 3. Okay, what's the type of this one? An even more partial application. Okay, so here, what's it going to be? Well, let's learn from our past experience. So this would be NMO, and then the type that's left, because we haven't supplied either of these two proof object arguments, will be n equals m and m equals o. So if 42 is n and a is m, then it's going to be 42 equals a. Okay, it's got to be this one. Let's check it. And indeed, that is the one that it is. Okay, I believe this next one is the last one. Okay, so here now we're saying, please infer all of this for us. Figure out what type we're working with, figure out what the values are, but I want to use H2 and H1, which is a different order than we've seen before. Okay, what is the type of this proof object? Think about it, pause the video if you need to. So let's see what these are. H2 here will be B equals 42. So that means if that's H2 is going in right here as this one, that means N is going to be B and M is going to be 42. Now H1 That's the second argument. That's going to be here. That means M is going to be A and O is going to be B. But we just over here said that M was going to be 42 because of H2. This can't work. And that fail keyword gives you the cue that it doesn't work. And it says, okay, let's see what the error message is. And there's a lot of text here, so it tells us everything it knows about. That's all this trash right, that we actually have up here anyway. The term H1 has type A equals B. Well, it is expected to have type 42 equals some O. That question mark being like, I don't know yet. And then it says the thing that actually tells you what you needed to know. Cannot unify A and 42. That's exactly what I said. I said, well, wait a minute. Here we learned that M had to be 42, and here we learned that M had to be A because we put H2 here, and 42 is the thing on the right. That'll match with M. And we put H1 here, and A is the thing on the left, and that'll match with M also. So Kak is saying, for once, exactly the problem, right? You're treating 42 and A like they're both going to be variable M, but those are two different things. Okay, if you didn't get all those quizzes, I think that's fine. We just learned this. Take your time. I want to encourage you to play around with these proofs and to play around with this technique. There are definitely going to be times when this will be the route to the fastest and clearest and easiest proof for you to do. It's a technique to hold on to. Okay, after this, we're going to go back to induction. We're going to do induction on some structures other than numbers, which will be fun. We'll do lists and trees. Going to be a great time. And then there's just some more exercises after that. Talk to y'all soon.